introduction after. Good evening. My name is Bruce Gillette. I am the moderator of Presbyterians for Earth Care. It is my joy to welcome you to this evening's program, the title of which is Climate and Weather, How the Extreme Global Weather Patterns Are Related to the Climate Crisis. And we are blessed to have a returning popular teacher with us. Dr. Colin Evans has done several webinars for Presbyterian for Earth Care that you can find on our website. He is a postdoctoral research associate at the Northeast Regional Climate Center at Cornell University, where he received his PhD a couple of years ago. He is a child of the community where I serve, of Owego, graduated from the high school here, the Owego Free Academy, and we're very happy to claim his mother as one of the gifted soloists in our church. He is a man well worthy of listening to and sharing, and I hope you will find it to be a wonderful evening. This is a church-related organization, and so we do start with prayer. Let us pray. Loving God, your love for us is everlasting. The weather can change. Some days it is beautiful, and some days it is stormy, and some days it is both. Through it all, you love us. And in turn, you call us to love and care for your creation, which in turn can have an impact on the climate, on the weather. Guide us, O Lord. Help us to be better informed about your creation so that we may care for it all the more. We give you thanks for Colin and for his wonderful gifts in research and in teaching. We ask your blessing upon him and his family and his important work. Hear all these prayers in the name of the head of the church, our Lord and our Savior, Jesus Christ. Amen. Please, Colin, take it away.
Great. Thanks so much, Bruce. And thank you, everybody, for having me again. I always find it exciting to be able to talk about climate change and what's going on with the climate crisis. I will first apologize. I am just getting over a cold and bronchitis. So I've got some water here, and if I fall into a coughing fit, I apologize ahead of time. But hopefully my voice will stay strong the whole time. Okay, so let's jump in. So the first point that I want to drive home tonight is that the weather does not equal climate. And basically that's the point of my whole talk. So thanks for coming, everybody. Have a good night. No, I'm just kidding. But really, I do want to drive this point home. So we're going to talk about this for a little while, and how even though we can experience very extremes in our day-to-day weather, that's not a good indication of what's happening with the climate. So let's start with, well, okay, what is weather then? Well, the definition from the American Meteorological Society says, as distinguished from climate. And I love that it starts with as distinguished from climate. Weather consists of the short term, so minutes to days, variations in the atmosphere, and is thought of in terms of temperature, humidity, precipitation, cloudiness, visibility, and wind. So basically everything that's going to affect you if you need to run out your door. That's weather. So then, okay, well, what is climate? And again, according to AMS, the slowly varying aspects of the atmosphere, hydrosphere, land surface system, and is typically characterized in terms of suitable averages for the climate system. Okay, so suitable averages is a little bit ambiguous. So what does that really mean? And if we look at the National Center for Environmental Information, their official definition is for a 30-year period. So if we're talking about weather, we're talking about a day or less. And for climate, we're looking at 30 years. So wouldn't be a good climate science talk without some math. So we're going to do a little bit of math here. So how much does weather then account for climate? So if we divide one day by 30 years, if you're kind of a math nerd, you know you can't do that because the units aren't the same. So let's convert that. So we've got one day over 10,957 days. That's roughly 30 years, counting for bleep years and whatnot. And so that comes out to 0.009%. Okay. So we can't really make conclusions about the climate on such a small sample size, right? Like that doesn't make any sense mathematically or even in, with your intuition. But I want to go through some examples that, maybe if you're not too much of a math person, that it might make a little bit more sense. So I'm a native of Massachusetts. I'm a big Red Sox fan, baseball fan. So I thought I could kind of compare weather and climate looking at some baseball information. So in 2023, the typical baseball game in Major League Baseball lasted 2 hours and 25 minutes, which, as a quick aside, is a much lower amount than any previous years. They introduced that pitch clock, and it really slowed things down. But we'll use the last year average to kind of look at this. So 2 hours, 25 minutes, 0.009% of 2 hours and 25 minutes is a whopping 0.783 seconds. So to make a determination about what's happening with the climate based on the weather is analogous to determining the outcome of a baseball game based on a single 0.783 seconds of that baseball game. Doesn't really make sense, does it? Looking at this another way, there's typically about 290 pitches in a baseball game, and 0.009% of 290 pitches is 0.026 pitches. So not even one single pitch. So if you wanted to determine the what happened with all 290 pitches, and you were going to use the weather as your example, you could only take 0.026 pitches to try and extrapolate what's happening through the entire game, to extrapolate what happened with every single pitch of that entire game. It doesn't really work out. Also, what even is 0.026 pitches? Well, I did the math because I thought it would be fun. And turns out it'd be about 1.6 inches of one pitch to determine the outcome of all 290. Right. So really, that doesn't work out. If baseball isn't your thing, the Super Bowl just happened on Sunday, 0.009%, you're looking at about 1/3 of an inch of the total 100-yard field. So if you want to know what happened across the entire field, you could only look at what happened one time over 1/3 of an inch. And again, you can't really do that, right? So you can't compare weather and climate. And one more, I'm really going to drive it home. I've really been into crocheting lately, and this is a temperature blanket that I actually crocheted. This is from 2022. Each row is a day of the year, and the colors correspond to the temperature of that day. So in total, and I counted, it has over 64,000 crochet stitches in it. And so if I wanted to do that same, ratio, that 1 day to 30 years, we'd have to determine the entire year's temperature based only on 5 stitches out of those 64,000. Okay. So weather does not equal climate. All right, let's get off the kind of abstract stuff, and we'll look at some real life examples. So some of you all might remember about 5 years ago, the polar vortex was going a little nuts, and the upper Midwest saw some record-breaking cold temperatures, right? Just unbelievably, -40, -50 degrees Fahrenheit. It was beyond frigid. And it was like that for several days. But interestingly, if you kind of take a step back and look at, well, okay, so that's what happened for those few days. What about the entire month? Well, despite those record-breaking cold temperatures, all it did was put the average monthly temperature towards their kind of quote unquote climate normal. So that 30-year period that you would account for climate, that's what it did. The rest of the month was actually warmer than normal. And those record-breaking cold temperatures just brought it to like near average. And so that's another example of why like looking at such short-term weather extremes doesn't give you the picture of what's happening with the climate. So why did those record-breaking cold temperatures happen? Normally, we have this very stable polar vortex above the Arctic. You've got this polar jet stream that's just circling around the Arctic. It's very cold. And it generally doesn't wander too far south. But unfortunately, climate change is making it unstable. So as warmer and warmer air moves northward from the equator, it's destabilizing that polar vortex. And what's happening is instead of a single polar vortex, you get this bifurcation. Excuse me, I apologize. You get this bifurcation in the polar vortex. And so you get these sweeping polar jet streams that come right down into the United States. And that's what happened back in 2019 over the Midwest is the polar vortex was disrupted. And you got those two, and we saw those record-breaking temperatures. And it's happened several times since then, and it's going to continue to happen as the equator gets warmer and warmer and pushes warmer air further and further north, disrupting that polar vortex. And one of the main reasons that this is happening is that the Arctic is warming faster than anywhere on Earth. So this map that we're looking at here is showing where on the globe places are warming either faster or slower than the entire average. And as you can really see, and what really stands out is the Arctic is warming a lot faster than the rest of the globe, as is Antarctica, which is also a real problem. And so some recent literature shows that the Arctic has warmed nearly 4 times faster than the globe since 1979, which is one of the leading causes of that instability in the polar vortex, and why we're going to continue to see these really extreme cold happening. I'm sure many of you remember that brutal ice storm that hit Texas a couple of years ago. That again was a result of this instability in the polar vortex, which is really a result of climate change. And one more kind of analogy to sort of drive this point home about weather and climate. I want you to think about if you were walking through this park and you want to get from point A to point B, and you're just going to follow this nice steady path. And that's sort of if you were the climate, you're going to just continue to rise up to point B. Well, if you were walking your dog and say your dog was on a 10-foot leash, as you follow this path, the dog can go ahead of you, it can go behind you, it can stop and sniff the grass for a while, it can do circles around you, right? But because you're the one holding the leash, it has to follow you, right? You can't get that far away. It's got to be within that 10 feet. And that's sort of analogous to like weather and climate. Weather is going to do all sorts of crazy things, but it's going to be driven by the climate. And that's sort of what's happening with climate change, except the leash is getting longer. And that's why we're seeing these really big extremes. It's because that leash, as you're going through the park, is getting longer, and so your extremes are getting bigger. So how do we know that the climate is changing? For me, one of the most convincing lines of evidence is that multiple meteorological agencies around the world have all come across the same information. So what we're looking at here is a graph showing observational temperature data from 6 major meteorological observatories. So this had one that's the United Kingdom. This is NOAA. That's, of course, the United States. This one is NASA. This ERA5, that comes from the European Union. This is from Japan. And the Earth is the University of California, Berkeley. They've had an excellent Earth observatory for the last like 175 years. And basically what they all show is the exact same thing as far as what's happening with temperatures. Basically lock and step, they're showing this increase in global temperatures independently. These are all independent observations from one another. And if this wasn't happening, if climate change wasn't a real thing, it wouldn't be showing up everywhere on the globe, all independently from each other. And the other thing is, we've known about global warming for a really, really long time now. The greenhouse effect was first proposed by John Tyndall in 1863, 161 years ago. Right, that was the first mention in a research paper about radiation and in the atmosphere, talking about the greenhouse effect. The first time someone mentioned that carbon in the atmosphere and its effect on temperature was in 1896. Again, 28 years ago. So these are things that we've known about for a really long time, and we have watched it happen in real time. And here in a paper from 1938, how the burning of fossil fuels would affect global temperature. So for almost 100 years now, we've known that as we burn coal, oil, and gas, we're releasing these greenhouse gases into the atmosphere, and it's gonna have an effect. And if you don't, want to believe me as a climate scientist, you could also take a look at what ExxonMobil knew in the 1970s. Some really just great research into internal documents from big oil showed that they had really impressively accurate temperature projections dating back to the 1970s, and that they knew as long as we continue to put carbon dioxide and other greenhouse gases into the atmosphere, the Earth would continue to rise. The Earth's temperature, would continue to rise. But they continued on with their business as usual, regardless. And that's just what we continue to see. Here is a graph showing daily surface air temperature, averaged across the globe. And that orange line is 2023. And for those of you that don't know, 2023 turned out to be the hottest year on record. Now, climate scientists have a lot of interest in kind of determining, where a particular year might fall. And if you had asked us, like in the middle of May last year, if 2023 was going to be a record breaker, we would have said no. We were coming out of a La Nina winter, which tends to cool things down for a little bit. And you can see that there were years where these months and days were higher than 2023. And then starting in June, 2023 blew up. And we saw the hottest June, July, August, September, October, November, and December on record by a lot last year. And so it ended up being that 2023 was the hottest year on record. And what I'm worried about now, I mean, it's quite early to hypothesize, but we're starting quite warm. This black line here, this black solid line is 2024. We're starting very warm, and we're currently in an El Nino, which tends to increase global temperatures. Will 2024 be a record breaker? Well, we've had the warmest January on record. February is already starting to look potentially like it could be the hottest February on record, but there's a lot of the year left, so we'll have to wait and see. It's still too early to tell. If we want to look at this visually, This is the observed warming we've seen since the pre-industrial period. You might hear a lot of talk about limiting global warming to 1.5 degrees Celsius. And that's for a global average. But if we look at different parts of the globe, many different parts of the globe have warmed beyond 1.5 degrees Celsius. In particular, the Arctic. As you remember, the Arctic and Antarctic are warming much faster than anywhere else on the globe. Everywhere on the globe is warming except for one place. And you can see right here off the coast of Greenland is this blob in the North Atlantic. It's actually a little bit cooler than average. And that always really stands out to me. And I find that really interesting. And you might be thinking, okay, well, what's happening there? Well, Greenland is warming, and we are dumping a lot of cold, fresh water into the North Atlantic, which is disrupting our ocean currents and is actually bringing cold water up here. And so that's why this is the only spot on the planet that's actually cooling a little bit compared to everything else. Again, looking at this visually, this is mapping changes in temperature every year. So here, each map is a single year, starting with the 1850s, 60s, all the way down through 2022. And I like this visual because it's really striking. You see how this has slowly shifted and that we're getting warmer and warmer and warmer. And there are so many different lines of evidence pointing to the fact that we're living on a warming planet. So, as I mentioned, the Greenland ice sheet is losing mass pretty significantly, dumping, again, a lot of fresh water into the North Atlantic. I don't really get into kind of the ocean currents in this talk, because I think that sort of deserves its own full hour. But that is definitely potentially a problem if our ocean currents get significantly disrupted. Our sea levels are rising, and sea level rise is actually a two-pronged problem. So the fact that we're dumping fresh water from land into the ocean as our Antarctic and Greenland ice sheet melts, that's not the biggest problem. It's actually thermal expansion. As the oceans get warmer, as you heat up water molecules, they actually expand. And so that's the bigger problem in terms of sea level rise is the thermal expansion, that just the fact that they're getting warmer and taking up more volume is a big problem in terms of coastal erosion and cities being inundated with flooding and high tides. There's been a lot of stuff in the news lately about Venice being flooded. Miami is spending millions, excuse me, millions of dollars trying to fight these rising tides. And unfortunately, they are currently losing that battle. As I mentioned, the Arctic sea ice is continuing to decline, and it's not outside the realm of possibility that we'll see an ice-free Arctic summer in the next 2 decades. That's definitely potentially possible given current trends. Antarctic sea ice is currently at is a record low for February, and we might see an all-time low here pretty soon. So what's causing all this? What's happening? As I mentioned, we've known since the 1800s about the greenhouse effect and how carbon dioxide in the atmosphere traps heat. And so the more carbon dioxide that we put into the atmosphere, the warmer it's going to get. So this is a record of atmospheric carbon dioxide concentration for the last 2,000 years. Direct air observations start right here in 1958, and the rest of these come from ice cores. You can see this incredibly sharp increase over the last 75 years. And now we're taking a step further back. Again, most of this data comes from ice cores. And this line here isn't the end of the graph. That is the straight line of increase in carbon dioxide. And it is far beyond anything we've seen in the last million years. Now, that's not to say that the Earth hasn't seen carbon dioxide levels this high before. They have, and higher. But of course, the problem that we're looking at now is the rate of change. So this rate of change is incredibly unprecedented and entirely unnatural. Looking at some more current information, this is the last year of carbon dioxide daily. These are taken atop the Mauna Loa volcano in Hawaii. And I was putting this presentation together and found this and was incredibly disturbed because we set a brand new record high of over 426 parts per million of carbon dioxide in the atmosphere. And that happened just last week. Typically, we set new highs at the beginning of summer, so more like May and June. There is this very observable trend in carbon dioxide where you get this rise and peak in May and June, and this decline throughout the rest of the year, which is due to the geography and geology of Earth. Most of our land mass is in the northern hemisphere, and so the peak happens right at the tail end, basically, of dormancy for the northern hemisphere. And as the northern hemisphere gets into spring and summer, the plants start to suck out carbon dioxide from the atmosphere, and that's why we see the lowest part right at the end of the summer, at the beginning of fall. So you see this annual cycle. So it's really disturbing to me that we observed this high of a value at this time of the year when everything is dormant already. So pretty interesting finding. But unfortunately, carbon dioxide isn't the only problem. We continue to put more and more methane into the atmosphere, and methane is about 25 times stronger than carbon dioxide. We're also putting more and more nitrous oxides into the atmosphere, and these are 250 times stronger than carbon dioxide. So those are also a problem. And we're seeing the consequences. More and more billion-dollar weather and climate disasters hit us every year. Last year we saw many of them, and yeah, we're just seeing this trend of more and more weather extremes and billion-dollar disasters as the years go on, which is clearly an impact of climate change. So that's a lot of negative information. So what are we supposed to do? Well, I'm sure many of you here have heard of this idea of the carbon footprint, right? And it's something we should all be aware of, our personal impact on the climate. No. I'm here to tell you, carbon footprint, your individual carbon footprint is a sham. Because the truth is, and this might shock some of you, any individual action you take is not going to be enough to combat climate change. The math just doesn't work. The data doesn't support that any individual action is going to make any kind of difference in the climate change. And it turns out that that big oil actually coined the carbon footprint idea to shift the blame from them to us as individuals. Because they wanted to keep pumping out oil and gas. Well, okay, well, what about recycling? Surely that's something we should all be doing, right? Well, who started the idea of recycling in the first place? It was big oil. The idea back in the 70s and 80s, they were getting a lot of flack for all of the plastic pollution. And so they started this recycling campaign. And it worked really well because we throw all kinds of plastics into our single sort bins and just kind of assume, okay, this is off getting recycled, when the truth is it's not. So only about 9% of the plastic that ends up in the municipal waste system actually gets recycled. Most of it, 50%, is ending up in regulated landfills. 22% is just dumped out. You drive down any road in America and you're gonna see tons of plastic pollution. Almost 20% of it is just being straight up burned, which is horrific. So I really, got to give credit to Big Oil because they, for a long time, were really successful in this recycling campaign and getting us to believe that we were actually like helping this plastic pollution problem. But we're not. And in fact, it's getting worse and worse and worse. And the problem is that there's too many kinds of plastic. So I'm sure many of you are familiar with all these different kinds of symbols. Number one is called polyethylene terephthalate. Say that 5 times fast. So these are soda bottles, water bottles, some food packaging, and it's commonly 31% of it is recycled in the US. And number two is high density polyethylene. So these are your milk jugs and laundry detergent jugs, some hair care cleaning products. It's 100% recyclable, but it's only the second most recycled. So less than number one, even though it's 100% recyclable. The rest of them, 3, 4, 5, 6, 7, they're going to be thrown away or burned. The industry finds it too cost prohibitive, too difficult to recycle those kinds of plastic. So they're just not going to do it. And we are really, really seeing the effects of this. We have found plastic in clouds, in rain. It's literally falling from the sky. We have therefore affected literally every inch of the planet with plastics. The oceans, not only are there huge garbage patches in the middle of the oceans, but now there are microplastics. And unfortunately, we at this point have no idea the extent to what kind of health and environmental problems these microplastics are going to cause. So that's really concerning. Okay, so again, what do we do? We need to fully understand the problem. And it comes down to energy use is the main culprit. And there are 3 main areas within energy use that we need to look at. So first is its energy use in industry. So this is producing iron and steel, producing gas and oil, food, machinery, and all sorts of other, anything you can think of as like industrial processes. Next one is transportation, including road transportation, planes, and shipping. And energy use in buildings, so both commercial and residential. And the only things that are going to affect real change are fundamental systemic change through legislation. That is what all of the data and research points to as the only thing that's truly going to solve the climate crisis. So number one, I understand that we're never going to get rid of cars. They're too convenient, and public transportation can't serve everybody. We have way too many rural populations that public transportation would just be impractical. But we have a solution to that, in that all cars sold need to be hybrid or electric or meet incredibly stringent MPG standards. Number two, we need an immense investment in public and commercial transportation, particularly in the form of railroads. We, in this country in particular, the United States, we need an alternative to flying. We fly way too much. If any of you have ever looked at like the flight tracker, there are so many planes in the sky. And we really need to cut down. And the only way to do that is if we make it affordable and convenient. And right now it just isn't, but we need to do it. Number three, all consumer plastics have to come from recycled plastics. The reason so much of our plastic waste isn't recycled is because there's no reason for these companies to do it. They're skating by with the idea that everything's getting recycled, so there's not a ton of demand from the public to hold them accountable. And there's no economic incentive for them to do it because it's too expensive to do the recycling. And they're, like I said, they're getting away with just using new plastic every time. And so if there was legislation then that made it so that they needed to use recycled plastics, that would definitely go a long way into revolutionizing plastic recycling in this country and abroad. Excuse me. And number four, we need a massive investment in retrofitting energy efficiency in our buildings. There is so much energy waste in homes, in commercial buildings, in terms of how we heat and cool our homes and buildings. Heat pumps and solar panels are readily available, but they're so cost prohibitive to so many people. And the thing is that I find both frustrating and fantastic is that we don't need a brilliant idea to solve any of those problems. We know exactly what we need to do. We just need leaders who have the gall to step up and say, yeah, this is what we need to do. It's going to be expensive. It's going to be inconvenient for a little while as we transition, but this is the only path forward to solving the climate crisis. Now, as I said, in terms of data and the math, your individual action in the scheme of things won't make a big difference. If you want to fly less, I think that's great, but there are plenty of celebrities who fly more in a single year than everyone on this call has in our entire lives combined, right? Like, that's just a fact. Like, there are so many celebrities flying every day, multiple times a day. But that's not to say that we shouldn't do these things either, because the truth is, data or not, we're trying to affect change at the generational level, right? And that's why I'm going to admit that I lied to you, because I do in fact believe that individual action is important. It may not mean anything in the terms of carbon release into the atmosphere, but it sure does mean something to Gen Z climate activists who are working really hard for a livable planet. And we owe it to everybody, every young person, to right the ship. For too long, we have just been using the atmosphere as a dumping ground. And we just can't do it anymore. Now, it's going to be tough. Like, no one has any delusions about how tough it's going to be. We're going to see more and more of these kind of headlines: soaring temperatures and raging fires, bracing for the most intense heat waves. Death Valley is the hottest place on the planet. It's going to continue to set record-breaking temperatures. We're going to see all of these kind of headlines, and people are going to get hurt. People are going to die. It's already happening. Last year, nearly 62,000 people died from the record-breaking heat in Europe. And these heat waves, like this is my area of expertise. They're gonna continue, they're gonna get worse. And unfortunately, people are going to get hurt. But we have to do it because there's no alternative. And something that really kind of gives me hope is what humanity is capable of. Of course, here on the left, we've got the Wright brothers at Kitty Hawk in 1903. And on the right, we're looking at Neil Armstrong in 1969. Only 66 years separate those two photos. That's an incredibly short amount of time for such an incredible technological achievement. And like I said, we don't need huge breakthroughs. They're happening and they're great. And the advances in solar panel efficiency and battery technology is phenomenal. But the thing is, we could do it with the technology that we have now. We just need, like I said, the will and the investment and the leaders to step up and do it. And I believe that we can, and we need to for a better habitable planet. Now, if you are looking for good resources for climate information, I won't list all of these, but I definitely will include these in the PDF and make that available to everybody. But these are some of the most trusted resources for information regarding climate science and climate change. And with that, I would be happy to take any questions.
Thank you, Colin. This was excellent. We'd ask people, if possible, to use the chat. I'm sorry, not the chat. If you go to the bottom of the Zoom to the reactions, and if you hit the raise hand in the reaction icon, that'll put you at the top of the screen so we can easily see you among the over 60 people who are on this site. And the first one to demonstrate he knows how to raise his hand is Dr. Mark Aiken, who did a webinar with Colin a few years ago. Mark is a retired NOAA scientist and a member of the steering committee of Presbyterians for Earth Care. Do you by chance have a comment or question, Mark?
I do. Thanks, Colin. Very interesting talk. And amazing. It's been a few years since the two of us did that talk together. It seems like yesterday.
I know.
A question for you. You were talking about the effect of the polar vortex and the bifurcation of the polar vortex and what that causes in terms of instability of the jet stream. This winter has been an interesting one. Something you didn't get into really is the El Nino and the impact that has on atmospheric circulation. And for just a little background to folks, normally when you have an El Nino going on, you get increased zonal flow, which means a lot of air going across in a nice straight line. You get cold temperatures in the north, warm temperatures in the south, and everybody gets kind of boxed in. When you have instability in the jet stream, you break that down, and that usually happens though in La Nina years, where you get a lot of this up and down motion. So this winter, we've had a lot of instability in the jet stream, despite being in an El Nino winter. And I'm wondering, sort of, what are your thoughts of this dynamic between the impact El Nino has versus what the polar vortex has had and what that meant to this year's winter?
I think if you remember that graph I showed you that was showing the daily temperatures, and how for 2023, up through May, it was, I don't want to say normal, it was still warm, but then starting in June. So I think all of this extra heat that we've had and continue to have is really disrupting what we know about El Nino and what we can expect from it. It's already a highly variable atmospheric phenomenon, and what we see in a typical El Nino isn't always that typical. Actually, one of my research projects for my dissertation was on how often we see, those kind of canonical effects from El Nino. And what I found was that it's actually not all that common. It's more often than not, those things don't happen. And so I think the inherent variability in El Nino, the inherent, you know, changes that we can see from it, combined with this massive amount of heat that we have in the atmosphere right now, is just throwing everything for a loop. And we're just kind of sitting back and watching and being like, this is weird. What is happening? I saw somebody put in the chat, my ski season has been ruined. Yeah, we've had, I mean, at like next to no snow. I just saw recently Syracuse, New York is like, I think it was 50 inches below normal at this time of the year. Yeah, it's just so, we're seeing it. We're seeing this instability in real time.
Juan, you have a question? Unmute, please.
Okay. Dr. Evans, I'm a gardener, and the USDA has, increased the zones or
Yeah.
warmer zones now, and it just bothers me because the rate is what you said is alarming.
Yeah.
So, I mean, I think they said there was something like 30 years that it took for them to test data and then change everybody by half a zone. So, I mean, are we looking at like in 15 years or 10 years, we're going to have another zone change? Because I love plants and I like native plants. And, like, can they move? They can't move that fast, to get into, it just seems like, and we also are looking for havens. So I'm just getting nervous as you talk. Anyway, I wanted to just point that out, that the rate is what you were expressing as very alarming, Okay, that's what I wanted to ask about.
Yeah, so in terms of like them actually changing the category for you, again, it's going to take a while because they want to see the data. But that's not to say that you're not going to see those effects in the next 10, 15 years. So you'll see them. You might not get the official word from, the I'm blanking on the wordage you just used.
USDA.
Yes, yeah, the USDA climate zones. But yeah, they are absolutely shifting. Spring onset is happening earlier and earlier. And yeah, things get weird. Last October, I had lilacs blooming because they thought it was like another spring. They had gone dormant, and then we had weeks of mild weather, and I had lilac blossoms in October, late October. Strangest thing I've ever seen.
Okay, our next one comes from a geographic location dear to Colin and me, the Finger Lakes. What do you have for us? A question or comment, Colin? Unmute.
Hi, Dr. Evans. Thank you for this presentation. And thank you for all the work you're doing, and for agreeing to educate the public. I know that that's really not part of your job description, but it's fantastic you're doing it. And this audience, I thank you for hosting this, Bruce, as well. The audience is great. My question to you is, have you seen the statement summarizing research that was done at University of Leeds, and also, let me see what the other one was, Imperial College of London, by Chris Smith and Robin Lambo, where they put out a statement basically saying, if humanity wants to have a 50-50 chance of limiting global warming to 1.5 degrees C, we can only emit another 250 gigatons of CO2, which is 250 billion metric tons. And basically, at the current rate we're emitting, it means we only have 6 years left to get to net zero. That's if we don't start rapidly decreasing it before that. to stretch out the carbon budget that we have left. Have you seen this? What do you think about this?
Yeah, I've seen that data come across in many different areas of research, and from different researchers, and that's basically true. We're not gonna hit net zero, in the next 6 years, and we'll definitely. We've already seen months where the average global temperature is over 1.5 degrees Celsius from the normal. It's only a matter of time until we see the entire year that's a degree and a half above. We're not going to meet that target. It's not going to happen.
Yeah, so basically my request to members of the audience that care about this, especially if you have children or relatives that are young, and even yourselves, many of us are going to be alive when things get to be really horrible here. I'm in my mid-60s. I'm going to see potentially many decades of horrible effects from this climate change. Right now, we're on a path to get to 2.5 degrees C of warming. 2 degrees C, all coral around the planet is dead. And also oxygen content of the oceans, the acidification of the oceans means that the protein output from fisheries around the planet is going to decrease. We're liable to have land-based agriculture start failing in a huge way too. So far, we've been insulated here in the US. But part of the reason why prices of food are going up is because of climate change effects already. Even in New York State, we have been having climate change effects. So if you have any inkling that you want to do something about this, make contact, email, phone, written letters to your elected officials at all levels of government and tell them you deeply care about climate change and you want them to act now, not 15 years from now, not 20 years from now, and not net zero by 2050. That's way, way too late. So thank you for listening to me.
Bruce, you're muted.
I think it's great to write representatives. I would also say organizing efforts to defeat politicians that are not actively working to change, to counter climate change. If there are politicians out there that are counter to that are part of the problem, we should do everything we can to defeat them. They should not be in office because they are threatening the lives of our children and grandchildren, national security, and everything else. But moving beyond that, Sierra Club would be a good organization to join. What, don't you think there? Let's move on to our next one. Thank you. Shirley?
Hi, this is actually her husband, Bob.
Okay.
I'd like to ask Dr. Evans what he thinks of carbon capture technology and what role that might play in the future.
We're going to have to figure it out if we want to get to net zero. I truly believe that. I actually have a really good friend and former colleague who's working really hard, figuring out how can we do this efficiently and cost effectively. And like I said, talking about, the jump from Kitty Hawk to Apollo 11, like that's incredible. It's incredible what we can achieve. And I really believe that we can do that. And my worry is that folks will say, oh, well, now we can just keep emitting carbon dioxide without, with impunity because we can just capture it. I think it's going to be part of the solution, not the solution.
Okay, Kage, I'm not sure how to pronounce your name, but we welcome our next speaker with a raised hand. Kaje. You're muted. We can't hear you. Well, since that individual's not speaking, we'll go to Forrest. Popular first name for this discussion. Forrest, do you have a question or comment? Unmute, please.
Yeah, carbon sequestration, a lot of folks are looking at trees as an answer. It seems like biochar And the hemp economy and olivine are ways that we could go. And the nice thing about the hemp, we could replace a lot of our fiber needs and sequester carbon faster and better, and save more trees and save trees for more useful things in paper and building materials and so forth.
Yeah, I think it's all part of the problem. It's incredibly complex, and I think that's what people have a hard time with. You know, they want an easy solution, and unfortunately, this is an incredibly complicated issue. And it's gonna take systemic change, top to bottom. We're gonna have to figure it out.
Question in the chat,
Agreed.
has anybody done a study of how war has impacted the environment? I know the Department of Defense United States is a huge user of energy without a war, but wars obviously have some impact. Any ideas on that one, Colin?
No, that's outside. I haven't done personally any research on that. I'm sure somebody has. Google Scholar is a wonderful resource. If you wanted to, just type something in and say environmental impact of war. I'm sure there's research out there.
I think there's a research group in Stockton that has done a lot on expenditures for military and war. That, if nothing else, it takes resources away from what could be allocated for clean energy, for transportation, for a lot of other things that could. And I believe President Eisenhower made that observation back in the late 1950s. Other questions? I'm sorry, I don't know how to pronounce your name, but the person who wrote Kaje and has their hand raised, if you're unmuted, please ask a question or make a statement. Or maybe not, okay? Other questions or comments? Well, what I'd like to do is plug a couple of things and then we will, okay, there we are. Still haven't heard you. Unmute, please.
Why was the question about the information on the Indians included in the question, or the identification you needed of the participants?
We asked to share that because as a fellow Presbyterian, Sarah, the National Presbyterian Church has encouraged people to lift that up in sensitivity for a variety of reasons, including to acknowledge that the land has not always been ours, for one thing. Also, issues of racial justice. I have your email address, Sarah. I will send you the page that explains it all. I can't tell you off the top. Maybe Mark or Mindy could add something to that beyond issues of land and also racial justice. Mindy or Mark, do you have anything to add on that one?
Sure. I mean, it is we've known for a long time that the land that we occupy was not empty before Europeans got here. There are people who have been stewarding these lands for generations before us, and we're doing a very good job of it. And so to acknowledge those who stewarded the lands upon which we live is a very important sensitivity to the people who came before us and whose land was largely stolen by European conquest. For those of you who don't know how to do that, I'll put a note in chat to a link called Whose Land that can go through and identify who were the people living on the lands where you live before Europeans came in and either forcefully removed them, killed them off through disease, or took other actions that has diminished their control over the land.
Mark, while you're on the screen, Kevin Millar has asked, and I'm sure your colleague here, Colin, could address the AMOC, which stands for, it's the Atlantic ocean current warming?
Atlantic Ocean, the Atlantic overturning meridional current or meridional circulation. It's the part of the circulation that goes on within the global oceans that moves water down to cold water down to the deep ocean, back up again and around and drives a lot of things. Slowing of the Atlantic Ocean meridional circulation is a way that has impacted the climate system. There are some places where there has been an increase in temperatures because we have less overturning going on. There's been some decreases that are measurable in the amount of circulation. And what Colin was pointing to is that very important cold spot, which is the result of all of the cold water, the melt from Greenland and the Arctic Ocean. The slowing of the AOMC of the sorry, it's AMOC. That's why I keep stumbling over it, is because it's the AMOC. Yeah, the Atlantic Meridional Overturning Circulation. And the impact on the climate system has been pretty marginal. There is an impact. There could be a long-term impact. The immediate impacts, however, being driven by a lot of other forces. And the AMOC is really more of a consequence than it is a driver of what we're seeing. Colin, your thoughts on this?
Could we take a brief break? We have been at this over an hour. I want to just do a couple of plugs, stop the recording, and then get Colin's input on what you just commented on. I don't want to stop the conversation. I just want to acknowledge we want to keep the recording within 1 hour. Our next scheduled webinar is on March the 14th on a Thursday evening at 7:30. We are happy to have Avery Davis Lamp from the Creation Justice Ministries, a large ecumenical group. They are having a special emphasis this Earth Day on Plastic Jesus, real faith in the synthetic world. And you'll note at the bottom there that Presbyterians for Earth Care have an overture going to our National Church Assembly on getting free from plastic pollution. Next slide, please. Starting tomorrow, which is Ash Wednesday, on the Presbyterian for Earth Care website, there is a weekly devotional all on lectionary texts dealing with creation care perspectives. So that starts tomorrow. It's a free devotional you can download or you can go back to. And help, we just had our steering committee meeting earlier today and our finances are not great. We need donations such as yours. You can give it very easily online to a secure website, to presbyearthcare.org/giving. Or if you want to put it in the mail, you go to the Presbyterian for Earth Care website and you scroll down and you have the mailing address. So please support our work. This was a free webinar. We're making it available online for free use in the future. The vast majority, 98% of what we get, comes from individual or congregational donations. So whatever you can give, $10, $100, 10,000, whatever, we'll take it with grateful hearts and make a real difference for God's world. Okay, Mark, you'd asked a question of Colin. Colin, be happy for you to field that. And those who have your hands raised, we will not leave until every comment or question has been offered.
Yeah, so I'll just mention, if anybody's seen the movie